Alright, in this video we are doing the same disk method, but this time it's being rotated about another axis. But you'll notice there's something in common with all of these, and it will help you understand why disk method is appropriate, not washer method. So first let's start graphing. We've got 2 minus x squared, and that's a downward facing parabola with a y-intercept of 2. Boom, center that. And then we've got y equals 1. It's going to go about there. And then notice that they're having us revolve around y equals 1. So that means there's no like inner radius to subtract. So let's go ahead and use disk method. This is going to be a dx integral. Volume is pi r squared. X is going to go from, oops. So if I plug in 1 for y, I would get x is equal to plus or minus 1. So this is going to be negative 1, comma 1, and this is going to be 1, comma 1. All right, so our x values vary from negative 1 to 1. And our radius, notice we're doing it like this. Our radius, actually, I mean, you don't have to worry about this part too much. You're always just going to take the axes value, so we're at y equals 1, and we're going to subtract the function height. So that's 2 minus x squared, and then that's our radius. So we're going to square it because we're doing disk method, pi r squared, and that's dx. If that radius thing feels a little bit uncomfortable to you, let's go ahead and check the radius function. So if we simplify this, our radius function is really 1 minus 2, which is negative 1. And then we've got negative, negative. So that's going to be positive x squared. So x squared minus 1. Now if we go over here, our bounds start at x equals negative 1. So let's double check that our radius should be 0 right there. So x equals negative 1. Our radius is 0. Let's double check that our radius should be 1 when we're at x equals 0. Sure enough, we get negative 1, but that doesn't really matter because our radius is being squared. And then last but not least, at x equals 1, our radius is back to being 0 again, which is perfect. So that guarantees that you've got your radius function correct. All right, the next one, we've got square root of x. Gonna look like this between y equals 0 and y equals 4. Y equals 0, x equals 4. Oops. X equals 4. And then we are revolving around that. This point here would be x equals 4 comma square root of 4, which is 2. This would be 4 comma 0. All right, so this is our region. We are rotating it about x equals 4. So we're going to do disk method, and that's going to be a dy integral. All right, so volume is pi r squared. Volume is equal to pi. Our y values vary from 0 to 2. And our radius value, so we're going to start at the axis that we're rotating about, which is positive 4, and we are going to subtract the function, which would be square root of x. We don't want x because we're doing a dy integral. So if we solve for x, then it's going to equal y squared. So minus y squared is what we want to subtract. That's our function, squared dy. All right, and again, if you want to check that radius, we'll plug our bounds in. So our radius function is 4 minus y squared. When y is equal to 0, our lower bound, our radius should be 4. Sure enough, plug in y equals 0, we do get a radius of 4. When we get all the way up to our upper bound, when y is equal to 2, our radius should be 0. So radius is equal to 4 minus 4, which is 0. Cool. Next one. negative x minus 2. So we're going to start down here at negative 2, and we're going to have a slope of negative 1. So something like that. This is going to be 0, comma, negative 2. And this is going to be, oh, actually, we're going way up here probably because we've got a line y equals 4 up here. And then also x equals negative 1. That's that line. So this point right here would be negative 1, comma, 4. We're rotating about this x equals negative 1 axis. This, if we set y equal to 4 and subtract 2, on the other side we're going to get, or add 2, 6 equals negative x, so x equals negative 6. So this is negative 6, 4. This is our region here. And we're rotating about x equals negative 1. All right, so we're going to do disk method, and we're going this way, so that's going to be a dy integral. Volume is equal to pi r squared for disk method, so we're going to go pi. Our y values vary from negative 2 all the way up to 4. Negative, oh wait, that is not true because that's not our bound right here. So when x is equal to negative 1, that makes it positive 1 minus 2, which is negative 1. So at negative 1, negative 1 would be that point right there. That means we're actually integrating from just negative 1 to 4. All right, then our radius, we're going to start with the axes we're rotating about, which is negative 1, and we're going to subtract the function, which needs to be in terms of y. So x, if we add the x to the other side, y plus x equals negative 2, so x equals negative 2 minus y. Negative 2 minus y, boom, that's our radius, square it, dy. And then again, let's do a little check on the radius function to make sure it works out. If we simplify this, this becomes negative 1 plus 2, which is 1. And then we've got plus y for the radius. All right, and we're starting at y equals negative 1. And yeah, our radius should be 0. So at y equals negative 1, our radius does indeed equal 0. And then when we get all the way up to 4, we get a radius of 5, which also checks out because we're going from negative 1 to negative 6. So that radius should be 5. All right. Next, we've got x cubed. So let's do that and that. X equals 0 is going to be right here. Y equals 8 is going to be way up here. This point, if y is equal to 8, then that must mean x is 2. So this point right here is going to be 2, comma 8. This is going to be 0, comma 8. And we're taking this shaded region bounded between all those lines. And we are rotating about y equals 8. So using the disk method, we're going to be having dx as our variable of integration. Volume is pi r squared, so that's going to be pi. Our x values vary from 0 to 2. And our radius is going to be, we're going to start at the line that we're rotating about, which is 8, and we're just going to subtract the function, which is already given to us in terms of x. So we're going to go 8 minus x cubed squared dx. Then again, if you want to check your radius, our radius function, we don't even have to simplify, just 8 minus x cubed. When we rotate first about x equals 0, our lower bound, our radius should be 8. So when x is equal to 0, do we get a radius of 8? Yep. When x is equal to 2, we should get a radius of 0. And yep, sure enough, 8 minus 2 cubed is going to be 0. All right. Number 5, first quadrant, sine of x, y equals 0 and x equals pi over 2. All right, so hopefully you remember from a unit circle that sine has a maximum value of 1 at pi over 2. So sine starts at the origin and then does this. Pi over 2 is going to be that maximum value. So this point right here is pi over 2 for the x. Our max of sine is 1. And then we're rotating around this line. So I take it this is the region they want us to use. Okay, so we're going to do disk method. And about that x line, we're going to have a dy integral. So volume is pi r squared. Pi, our y values go from 0 to 1. This point here is 1 comma 0. Nope, pi over 2 comma 0. 0 to 1 for y. And our radius is just going to be starting with the line that we're rotating about. Which is pi over 2. And then we need to get our function in terms of y. So hopefully if you remember, to solve for y here, you'd have to take the arc sine of both sides. So x is equal to arc sine of y. All right, so then that's what we're going to subtract. And we're going to go ahead and square that and dy. I'm not going to bother to, well, I suppose we could check our radius here. Radius is pi over 2 minus sine inverse of y. When y is equal to 0, sine inverse of 0 is like saying at what angle does sine equal pi over 2. And when y is equal to 0, our radius function is just given by that. I'm not going to copy it. Sine is 0 at 0. So that means our radius would be pi over 2 minus 0, which is pi over 2. And yeah, when y is equal to 0, our radius is pi over 2. And once we get all the way up to y equals 1, sine inverse of 1 is like saying at what angle does sine equal 1? And that's at pi over 2. So our radius would be pi over 2 minus pi over 2, which is 0, which checks out because we think our radius would be 0 once we integrate all the way to the tippy top. All right, cool. Next one, negative x squared negative x squared minus 2. So that's a downward facing parabola, not negative 2. Center that. And then y equals negative 3. It's going to be about here. And then this is going to be our shaded region. These points are going to be whatever. Okay. When y is equal to negative 3, we can add 2. That would just be negative 1 equals negative x squared. So x is equal to plus or minus 1. So this is going to be 1 comma negative 3, and this is going to be negative 1 comma negative 3. All right, so we're going to do disk method, and that's going to be dx's. Okay. So for our volume, we're going to have pi r squared. Our x values vary from negative 1 to 1. And our radius, we're going to start at the line that we are rotating around, which is negative 3. And we're going to subtract our function, which is negative x squared minus 2. Put parentheses around all of it, square it, and dx. That is so annoying. Okay. And then for our other, oops, we can do our radius check. We've got our radius is equal to -3 plus 2 would be -1, and then plus x squared. Okay, so at x equals -1, our radius should be 0. And if we plug in -1 squared, that's going to be +1. -1 plus +1 is 0. When we go to x equals 0, our radius should be 1. And yeah, we get -1, but again, that's okay because we're squaring our radius in the volume. And then when x is equal to 1, we also get a radius of 0, which checks out. Those are the 3 different radius values we just checked. All right. Now we've got a x squared minus 3, so upward facing, but shifted down to -3, so something like this. And then line at y equals -2, and we're rotating about this line. Oops. Okay, the intersections, if we set y equal to -2 and add 1, we'd get 1 equals x squared, so x is equal to ±1, so this is going to be -1 comma -2, this is going to be 1 comma -2, and we're going to do disk method. This is going to be also a dx integral. Volume is pi r squared. Our x values vary from -1 to 1 again. Our radius, we're going to start at the line that we're rotating about, which is -2, and we're going to subtract the function, which is already given to us in terms of x, so x squared minus 3, parentheses around all of it, square it, dx. Let's do a quick radius check. Our radius function that we just wrote is -2 plus 3. It's going to be 1 minus x squared. When x is equal to -1, our radius should be 0, which it is. When x is equal to 0, our radius is 1, which checks out. And when x is equal to 1, our radius is 0, which checks out. Okay, last one. We've got y equals -x squared. All right, so when x is equal to y squared, that's either going to go this way or this way. And when it's y equals -x squared, think it goes on the negative side. So hopefully that makes sense. And then x equals -4 is going to look like this. And we're going to rotate about x equals -4. So this is our region. If we're rotating about x equals -4, that means our disks are going to be dy disks. So we're going to do a y integral. Volume is pi r squared. Our y values are going to go from, so here x is -4. Our y value should be -2. And up here, when x is positive, or still -4, our y value would be +2. Okay, so we're integrating from -2 to 2, and our radius is going to be the function, which is given to us in terms of y, we got to do the axes that we're rotating about, which is -4 minus -y squared, all squared dy. Let's do a little radius check. Our radius equation then is -4 plus y squared. When y is equal to -2, we should get a radius of 0, which -4 plus -2 squared would be +4. That is going to be 0. When y is equal to 0, when we're right in the middle here, our radius should be 4. And if we plug in 0 into our radius equation, we get -4, which again is okay because we are squaring the radius. Okay, and then when we get all the way up to y equals 2, radius is also equal to 4. All right, well, hopefully that helps you understand how to set up these off-axis problems.